My proposal to cope with the energy crisis I've explained consists of the following 3 points. First, we must decentralize the energy infrastructure, that is, from a large-scale centralized power station to many small-scale distributed power stations. To do so, we can avoid the loss of about 5% of transmitting electricity from the remote power station to the consumers. Furthermore, we can use wasted heat produced when the electricity is generated, so that the total efficiency of energy usage will rise. The second point is the change of the energy storage medium from the carbon, such as petroleum, to hydrogen, such as hydrides. In this changing of the energy storage medium, the primary energy should be produced at appropriate locations. For example, photovoltaic power stations should be constructed in the desert region where the sufficient sunshine condition and large area to be set up are fulfilled. Furthermore, the wind power stations are going to be constructed offshore where the strong wind of more than 5 meters per second is expected. The energy usage rate in Japan is so high that it is difficult to rise it up more. However, there are a lot of countries where the energy usage rate is poor. Therefore, rising the energy usage rate in the world brings in surplus energy, which can in turn be sold to another country. In this case, we have to construct a highly political world trade system to return the surplus to Japan. The third is a vital transportation means, that is to say, a hydrogen ship. I will talk about in detail later. After the World War II, Japan rebuilt herself as a trading nation. That is to say, Japan imports many raw materials from abroad, such as crude oil from the Middle East, mineral resources from China and Australia, and manufactures value-added industrial products using these raw materials. Then exports these value-added products to the US and EU to gain foreign currency, which will in turn spend to obtain the raw materials. This circulation sustains the trading country Japan until now. However, after Lehman shock, the financial circulation had already broken down, and further, Fukushima nuclear disaster broke down the traditional world trading system, since many countries stopped import Japanese products for fear of radiation contamination. This change is worldwide and irreversible. Thus, the system should be changed hereafter. This sheet shows the blueprint of Japan in the world. Japan has to change her environment to use energy resources sustainably. The new scheme to get sustainable energy resources consists of the following 3 points. The first step is that Japan exports energy-efficient technology such as Solid-Oxide fuel cell and catalytic reforming technology to low energy usage efficient countries. As a result, Japan obtains foreign currency. The second step is that energy efficiency of the Southeast Asia lies high enough to export their surplus energy, such as natural gas, to abroad, because they now have high efficient energy system. The third step is transforming this surplus energy into hydrides, which are more convenient for marine transportation and storage than gas. Here, the hydrogen ship as a petroleum-independent transportation means will be used. This ship will be used after all the petroleum-dependent ships are out of work because of lacking fossil fuels. By this scheme, Southeast Asia countries can get foreign currency and Japan can get energy resources. The hydrogen ship is an electrical propulsion ship equipped with a fuel cell, which acts as a generator many kinds of fuels can be used, such as methanol, ethanol, or hydrides, including hydrogen. These tables compactly summarizes the structure of the new energy system we are proposing. In this new energy system, the main part of the system is based on the secondary energy, which is used as energy storage and transportation media. Their practical visualization is methanol, ethanol, hyperhydrides, and biohydrides, which are almost the same as ethanol. The hyperhydride, which is well known as chemical hydride, is the most efficient medium for storage and transportation of hydrogen. These fuels can be used to supply hydrogen to a fuel cell efficiently. Since hydrides can absorb hydrogen again after having discharged hydrogen, recycling is easy. Under the platinum catalyst, both storing and releasing hydrogen are reversible. To charge hydrogen, the renewable energy as the primary energy can be used to electrolyze water. Biomass also can be used to provide bioethanol. We can obtain the required electric power from fuel cells fueled by these hydrides. It is worth to note that this repeated usage of energy stored media is quite different from our current energy system, in which energy stored media such as petroleum, coal, and natural gas are going to be consumed reversibly. After fossil fuels burn out to get heat power, nothing remains. Furthermore, in the new energy system, remaining coal and natural gas are used as raw materials for energy storage such as methanol and hydrogen by catalytic reformers. Electricity generation is the process of generating electric energy from the other forms of energy. Electricity is most often generated at a power station by electromechanical generators, primarily driven by heat engines fueled by chemical combustion of fossil fuels such as petroleum, coal, and natural gas, or nuclear fission, but also by other means such as the kinetic energy of flowing water and wind. There are many other technologies that are used to generate electricity, such as solar photovoltaic cells and geothermal power. A heat engine such as steam turbine, gas turbine, and diesel engine drives a generator which converts mechanical energy into electricity by magnetic induction. Photovoltaic panels convert sunlight directly to electricity. Chemical electricity generation, known as a fuel cell, is the most important in the new energy system, since a fuel cell directly converts chemical energy from a fuel into the electrical energy. In a large-scale thermal power station, water is heated in boilers, turns into steam, and spins a steam turbine, which drives an electric generator. Its overall generation efficiency ranges from 30 to 53%. On the other hand, a fuel cell has high generation efficiency ranging from 35 to 60% because it converts chemical energy from a fuel directly into electric energy. In addition, the fuel cell captures some or all of the byproduct heat for heating process, potentially reaching the energy use efficiency of 80%. This means that less fuel needed to be consumed to produce the same amount of useful energy. A fuel cell is a device generating electricity in the process of making water from hydrogen and oxygen. It converts chemical energy from a fuel directly into electricity. The principle of a fuel cell is the inverse reaction of electrolysis of water. It takes out the energy that hydrogen and oxygen have as electric energy, not through combustion of them. The maximum theoretical efficiency is about 85% in the case of hydrogen-oxygen reaction. Fuel cells generate electricity without any noise and vibration. Furthermore, they don't emit any dangerous pollutants such as sulfur dioxide and nitrous oxide. Many types of fuel cells are possible. Hydrogen fuel cell, a type called polymer electrolyte fuel cell, DEFC, uses hydrogen as its fuel and oxygen as its oxidant. Other fuel includes hydrocarbons, alcohol, and chemical hydrides. A type called solid-oxide fuel cell, SOFC, uses natural gas, mainly methane gas, as its fuel and oxygen. A type called Direct-Methanol fuel cell and a type Direct-Ethanol fuel cell, DEFC, uses alcohol such as methanol and ethanol respectively as their fuel. Rigid fuels such as alcohol and chemical hydrides, we call them hyperhydrides, as explained later, are preferable to gaseous fuel because they are easy to be stored and carried. From now on, I will introduce briefly several types of fuel cells. The fuel cell that uses the methanol liquid at normal temperature for fuel is called Direct-Methanol fuel cell, DMFC. Because methanol is more suitable for store sale and carrying around them gaseous fuel, a wide use of car and mobile devices is anticipated. A typical output power is about 3 kilowatts with nominal electrical conversion efficiency of 40%. Net efficiency is called to be 20 or 30%. It works at 100 degrees Celsius. A major disadvantage of the DMFCs as a result of the low temperature operation is that platinum or similar type of expensive noble metals are usually used as a catalyst. It is a cost that prevents the widespread use of DMFCs. So many companies are working on technique to reduce cost. Ethanol is an ultimate environment-friendly fuel since methanol is a little poisonous and highly corrosive to rubber. Many companies are trying to replace methanol to ethanol as a fuel. The fuel cell that uses ethanol for fuel is called Direct-Ethanol fuel cell, DEFC. However, its status is in the research pipeline. A DEFC is one type of polymer electrolyte fuel cell. Its ultimate waste product should be water and carbon dioxide. However, at present, its reaction byproducts are acetaldehyde and acetic acid. A solid-oxide fuel cell, SOFC, is extremely advantageous because of a possibility of using a wide variety of fuel. Unlike most other fuel cells, which only use hydrogen, SOFCs can run on hydrogen, butane, methanol. However, it only works at very high temperature, typically about 700 degrees Celsius. As a result of such a high temperature operation, at the anode, SOFCs can use nickel or other inexpensive metal catalyst. Its electrical conversion efficiency is about 55% and its output power is about 6 kilowatts with a fuel flow rate of 10 liters per minute. To deliver the desired amount of energy, the fuel cells can be combined in series and parallel circuits, where series yield high voltage and parallel allows a higher current to be supplied. Series combination design to get the desired voltage is called the fuel cell stack. The number of cells in a stack determines the output voltage. Each cell's output voltage is almost fixed. The number of parallel combinations of the cell stacks can be increased to allow stronger current from the parallel array of cell stacks. The concept of dynamic fuel cell is that by connecting dynamically a lot of fuel cell stacks in response to the load on the basis of smart grid architecture, the number of parallel combination of cell stacks in operation is controlled by pumping fuel.